Hi again, folks. In the last video, we looked at the relative demand of good G relative to good K under a CES utility function. Now I want to look at absolute demand, so Marshallian demand. Now, if you recall, Marshallian demand for a good Xig, I'm going to put a little superscript M there for Marshallian. It's just a function of prices, so it's going to be a function of all prices, P1 to PG, and the income of the consumer. So we want to find a way to take our first order condition that we derived in the previous video, and you see at the top here, and get a function of Xig that is purely a function of prices and the consumer's income. It's very easy once you know how. It's a three-step process. The first thing I'm going to do is I'm going to rearrange the first order condition in terms of Xig. So I can divide by this a to the power of 1 over sigma minus 1 and by alpha g to the 1 over sigma, and then raise everything to the power of minus sigma. And in doing that, I get alpha g lambda I to the minus sigma pg to the minus sigma times a to the sigma over sigma minus 1. Okay, that's step one. Step two is to find a way to substitute out lambda I and a. So the first thing I'm going to do is I'm going to take our first order condition again, and I'm going to multiply it by Xig. So that's step one, I guess. This is step two. So I'm going to take our first order condition. I'm actually going to leave a little bit of a gap between this a and the alpha term. And I'm going to multiply this by Xig. So Xig to the power of minus 1 over sigma times Xig is just Xig to the power of sigma minus 1 over sigma. And on the right-hand side, I'm going to get lambda I, and again, I'm going to leave a little space, and I get PG times Xig. Now I'm going to sum up both sides of this equation with respect to G. So A here, remember how we defined A from the utility function, this is already a sum over G. So this we can take this outside and just sum this alpha G Xig term over all the G's. On the right-hand side, lambda I doesn't depend on G, so we can take that outside of the sum. Do this. Now, what are these terms? Well, this term here, this is just A. This is how we defined A. And on the right-hand side, this is our total expenditure, which from our budget constraint, we know is just going to be equal to our income. So simplifying this slightly, we get that A to the now sigma over sigma minus 1 is just equal to lambda I times yi. So we can use this to substitute out A to the sigma over sigma minus 1 from our first equation. But let me not do that yet. Let me move on to step 3, which I'm going to take our first order condition again, and I'm going to raise everything to the power of 1 minus sigma. So if I take A to the power of 1 over sigma minus 1, raise that to the power of 1 minus sigma, I just get A to the minus 1. Alpha G, I get to the power of 1 minus sigma over sigma. And Xig to the power of sigma minus 1 over sigma equal to now lambda I to the 1 minus sigma times PG to the 1 minus sigma. I can't do anything with this yet because this alpha g is not quite to the right power. So what I'm going to do is I'm going to multiply both sides by alpha g. A to the minus 1. And again, I'm going to leave a little space. If I multiply this by alpha g, I just get to the power of 1 over sigma there, xig and I1 minus sigma. Again, I'm going to leave a little space. I get alpha g here because I multiply both sides by alpha g, and then pg to the power of 1 minus sigma. And now again, I can sum over all the g's. And again, because A is already a sum of the g's, I can take that out. And because lambda does not depend on g, I can take that out. And again, on the left-hand side here, we have the definition of A. And on the right-hand side, we have a sum. We can't do anything with that yet, but on the left-hand side, we have A to the power of minus 1 times A. So that obviously simplifies. And rearranging slightly, I get that lambda I to the power of 1 minus sigma is just equal to 1 over this term on the right-hand side, which I'm moving to the left-hand side now. Okay. Now I can substitute both of these equations. I'm going to call this equation 2, I'll call this equation 3, because they're from step 2 and step 3, into equation 1, which is the equation from step 1. And I get first substituting in equation 2, I get that A to the power of sigma over sigma minus 1 is just equal to lambda I times yi. And I can combine these lambda I terms to get lambda I to the power of 1 minus sigma times yi. And I can then substitute in equation 3. So I get that xig, the demand for good G, is just equal to this function of prices. And it's a function of all prices, as I said it would be. Remember, in the denominator here, we have a sum over all the G's, so of all the different prices, and of the consumer's income, which is just yi. So this, I'm just going to write xig here. This is our expression for Marshallian demand of good G. There's a couple of things we can note here. If we multiply both sides by PG, so I'm just going to rearrange on the left-hand side is now the right-hand side, and divide both sides by the consumer's income, we get the consumption share of good G on the left-hand side, and that is equal to alpha G PG now to the 1 minus sigma, and the denominator is unchanged. So what you can note here is that if all prices were the same, if for all PG, for G PG equals some price P, then I just get the consumption share PG xig over yi is just equal to alpha G times P to the 1 minus sigma divided by P to the 1 minus sigma, and I can now pull all the P to the 1 minus sigmas out and just divide both the top and bottom, or just cancel the P to the 1 minus sigma on the top and bottom. So we get that the consumption share is just these functions, this function of all the alphas. And if, as is typically the case, we say we assume that the alpha g's sum to 1, then we just get that this is equal to alpha g. So in other words, the consumption share by consumer I of good G with a CES utility function, if all prices are the same, is just equal to this alpha G. The other thing we can note is that these consumption shares sum to 1, as you would expect they would. So if we go back to allowing prices to differ for different goods, if we then just sum over PG XIG, if we sum over all the G's, the denominator is already a sum over G, so we can leave that out. Clearly on the right-hand side, these two things cancel and it's just equal to 1. And on the left-hand side, yi is obviously not dependent on G, so we just have the sum of the consumption shares of each good sum to 1, as you would expect. Okay, but the key point of this video is just to show you how to derive the Marshallian demand of a good under a CES utility function. Thanks very much. See you in the next video.